Okay, we are going to work today on a new method of solving systems of equations. So we've talked about graphing so far. We're going to talk about a new method. So by the end of this lesson, you will be able to solve a systems of equations using the substitution method. So take a look at this graph. Actually, this is supposed to be moved over a little. But why is graphing not always a good method? It's not always a great method because sometimes we cannot tell exactly where two lines are meeting. So graphing is helpful to visualize the three types of solutions that we've talked about, which is no solution, one solution, or infinite solutions. The solutions to a system of equations is the point at which lines intersect. So the idea is to determine which method of solving a system is easiest for that problem. So it may not always be graphing. Today, we're going to talk about a method called substitution. Okay, this is a review of your graphing lines. So we have parallel lines, which means no solution, intersecting lines, which means one solution, and coincident lines, which means there are infinitely many. So when do we use substitution? So substitution is a really great method to use if one variable in one of the equations is already isolated or by itself, okay? Or if it has a coefficient of 1. Substitution can be used for systems of 2 or 3 equations, but many prefer other methods when you get to 3 equation systems. We're just working on 2 equation systems today. So for this example here, we have x plus y equals 5. So both x and y have a coefficient of 1. And in this bottom equation, y is already isolated, meaning it's by itself. There's no other variable with it. So this would be a perfect time to try and use substitution. These are the steps for solving this using the substitution method. The first thing you're going to do is solve an equation for one variable. Pick the equation that's already solved for y or has a coefficient of 1 for x or y or whatever your variable is. Once you have your variable by itself, you are going to substitute that equation into the other equation. From there, you're going to solve the equation for the variable that's left. Then you're going to take that number and plug it back into the original equation to solve for the other variable. Then you can check your solution. So that's a lot of words, but let me show you these steps using a problem. So we have x plus y equals 5 and y equals 3 plus x. Step 1, solve one equation for the variable. Well, if we take a look here, this bottom equation is already solved for y. So that's done. Step 1 is done for us. Step 2, substitute. Okay, so what I said was we are going to take the equation that's already solved with the variable isolated. This one is y equals 3 plus x. Y equals 3 plus x. So that means in my other equation up here, instead of putting y, I'm going to put 3 plus x. So here's the original equation, x plus y equals 5. Now I'm going to have x plus 3 plus x equals 5. Solve the equation. So x plus x gives me 2x plus 3 equals 5. I'm going to subtract 3 from both sides. 2x equals 2. Divide by 2, divide by 2, and I get x equals 1. So step 4 said to plug that variable back in to find the other variable. So x does not equal x anymore, it's 1. So now I have 1 plus y equals 5. So again, I'm going to solve for y now. So I solved for x. Now I know what x is, so now I'm going to go back and solve for the other variable. So I know that y then would be 4. and then I'm going to check my solution. So I know that I think my solution anyways is 1, 4. So I would plug it in. I'd say, okay, x plus y equals 5. So 1 plus 4, does that equal 5? Yep. Then I have y equals 3 plus x. So 4 equals 3 plus 1. Yep. So therefore, my solution is 1, 4. I have a question down here that says, what do you think the answer would be if you graphed the two equations? Well, if I graphed the two equations, I should get the same solution. Substitution is just a different method of solving systems of equations. So some people might find it a lot easier to substitute than to actually have to graph these. All right, so remember we talked about solutions or systems of equations have one of three solution types. They either have one solution, they have no solution, or they have infinitely many solutions. So how will we know if we're using substitution how many solutions it has? Okay, because in graphing we looked at the lines. So when you're doing substitution method, you will get one solution, like in the problem we just did, when it has one value for x and one value for y. You will have no solution when substitution results in a false statement. So if you were to try to solve for a variable and you get something like 4 equals 9, 4 does not equal 9. So that means there is no solution to those systems. And then you will get infinitely many solutions when a substitution results in a true statement, such as 4 equals 4. This doesn't apply to your check part of your solving. Okay, so when you go and check your solution, you should get a true statement, but this is saying the variables go away when you're trying to solve for them, and you get a true statement. So let's take a look and practice some of these. Alrighty, so solve the system using substitution. So remember, the first thing we want to do is check and see if any of them have a variable already isolated by itself. That is not the case here, but we do have a variable with a coefficient of 1. So we're going to go ahead and get that one by itself. So we have 3y plus x equals 7. I'm going to subtract 3y from both sides. So I get x equals 7 minus 3y. Okay, so I'm going to take this expression here, 7 minus 3y, and plug that in the other equation for x. So I have 4. Now, instead of 4 times x, I'm going to do 4 times 7 minus 3y minus 2y equals 0. I'm going to distribute this 4. 4 times 7 is 28. 4 times negative 3y is negative 12y minus 2y equals 0. I'm going to combine like terms. Negative 12 minus 2 is going to be negative 14y. And I want to get y by itself. So I'm going to add 14y to both sides. So I'll get 28 equals 14y. Now I'm going to divide by 14. So y equals 2. Okay, so now what I'm going to do is take 2 for y and plug it in. So now I can solve for x. So 3 times 2 plus x equals 7. 3 times 2 is 6. 6 plus x equals 7. We know that x has to be 1. So our solution would be 1, 2. And again, you can plug in 1 for x, 2 for y, and make sure that they're true for both systems of equations. Okay, let's look at this one. So we have x already isolated by itself. So that makes it easy for us because we're going to come over here. We're going to take this equation and plug it in. So instead of putting x plus y equals 7, x is 3 minus y. So 3 minus y plus y equals 7. Well, I have two y's over here, so I'm going to combine like terms. Negative y plus y. That's going to cancel out. So I'm left with 3 equals 7. Does 3 equal 7? That is a false statement. So this is where we would have no solution. All right, let's take a look at this one. Again, we have x already isolated by itself, so that's really great. Instead of x, I'm going to plug in 4y minus 17 minus y equals 4. 3 times 4y is 12y. 3 times negative 17 is negative 51. And then minus y equals 4. So we're going to combine like terms. 12y minus y is going to be 11y. I'm going to add 51 to both sides. So I would get 11y equals 55. Divide by 11. Y equals 5. So what I'm going to do is take that y value, plug it in, and solve for x. So 3x minus 5 equals 4. Add 5 to both sides. 3x equals 9. Divide by 3. So then x equals 3. So our solution would be 3, 5. Hopefully you're kind of starting to get the hang of it. All right, let's take a look at this one. So this one we're going to have to manipulate a little bit ourselves because we don't have a coefficient of 1 and we don't have one that's already isolated. So let's go ahead and take this top one. And we're going to solve for, we'll solve for x. So let's go ahead and move that y over. So we have 2x plus 4y equals 4. I'm going to subtract 4y. 4 minus 4y. And then divide everything by 2. So x equals 2 minus 2y. All right, so now I'm going to come up here and plug that in. So 3 times x. So 3 times 2 minus 2y plus 2y equals 22. All I did was take this equation here. Instead of x, I plugged in 2 minus 2y. So 3 times 2 would give me 6. 3 times negative 2y is going to be negative 6y plus 2y equals 22. Negative 6y plus 2y is going to be negative 4y. I'm going to subtract 6 from both sides. Negative 4y equals 16. Divide by negative 4. Y equals negative 4. I'm going to take that negative 4 now for y and plug it in. So I would have 2x plus 4 times negative 4 equals 4. 2x, oh, that's going to be 2x minus 16 equals 4. I'm going to add 16 to both sides. 2x equals 20. And x will be 10. So that means our solution will be 10, negative 4.